Hi guys, this is how to do the transportation method. So basically first, we're going to create a table which we have now here. Now of course, this will vary based on the given, but this is the example that mom used. So this is an example of a balanced transportation problem since the total sum of supply and demand is equal to each other. So when you add the rim values, these are your rim values. And here as well, when you add these values, you get 700 and 700, meaning this is a balanced transportation problem. So, by the way, these are all unused cells, and this is your cell cost. And then if you had a value, let's say 500, this would be your cell entry. So, anyways, first is creating the constraints. So after you have your tables, you create the constraints. Now, how to make the constraints? We simply do. So let's write here constraints. So basically, do it this way. So since this is a minimization problem, we do min c equals $ 5dA plus. So this is how we do it. So we will go by row. So we will go by first row, second row, and third row. So we will go 5dA plus 4dB plus 3dC. So if we were to write that, 5dA plus 4dA plus 3dC. Then next, so this is your first row, right? Next, you would do the second row. So this is gonna be a bit long, but 8EA 8EA plus 4EB, right? Then last but not least, 3EC 3EC. Then let's just move it to the next so that we have next what do you call this? So we have space. So next is this row, third row. So 9FA 7FB, then next is 5FC. So this is your constraint, right? Sorry. That is correction. This is rather the objective function. My bad. Objective function. So you can see here that this is your first row, right? Here. The next is your second row, here. And next would be your third row for your objective function. Now, after you create your objective function, we get the constraints. So actually, let's make the constraints here. Maybe here. Constraints. So for the constraints, it's also simple. So we go first by row. So we go by row. Then next, we go by column. So I'll show you what I mean. So constraints such that dA plus dB plus dC is greater than equal to 100. And the reason why we're using greater than equal is minimization. Remember, if it's a minimization problem, it's greater equal, and if it's a maximization problem, it's less than equal. So anyways, as you can see here, we did dA, dB, and dC is greater than equal to 100. Okay? So we're done with this row. Next we do this row. So EA plus EB plus EC is greater than equal to here 300. Then next is the third row. We do FA, FB, FC is greater than equal to 300. So now we're done with the supply, right? Because we're tackling the supply here, 100, 300, and 300. So now we're done with the row. Supply, let's put here supply, row. Now we're gonna do it by column in order to fulfill the constraints for the demand as well. So how we do it would be DA, EA, FA. So DA plus EA plus FA is greater than or equal to 300, because in this column the demand would be 300. Next column here would be DB plus EB plus EC. Right. Sorry. Let's go back a bit. DB and then EB and FB. Right. Greater or equal to 200. Then for the last column, we do FC, because we're now here. So make sure you don't get sidetracked. FC. Sorry, let's start with D. DC, EC, and FC is greater than or equal to 200, such that all variables is greater than or equal to 0. Because remember, no negative values, because that would be invalid. So finally, we have our demand constraints, which is the call for column. So let's double check that. DA, EA, and FA. Then DB, EB, and FB. That is here. Then last is here. DC, EC, and FC. So everything's right. So after doing that, now that you have your constraints, we can now move on to entering cell entries using the northwest corner method. So let's put here cell entry with northwest corner method. Alright. So actually, let's copy the table again. And then we paste it here. And we put it here. Alright. So after we have this here, how it would work is we go to the northwest corner, and the northwest corner, so north and then west, right? So basically, let's just go into the topmost left corner, and this would be your topmost left corner. Then you would enter the values or entries that would satisfy your supply or your demand. Now here, in order to satisfy 100, we must put 100, right? So since this is satisfied already, there's no more entries that you have to put in order to satisfy 100. This would now be left blank, okay? However, alright, we can just do that. So now here, in this column, currently we have 100, right? 300 minus 200, 100 is 200, right? So you need 200 more to satisfy this. So let's try to do that. 200. Now, 100 plus 200, 300. So we satisfy that. However, we don't satisfy this. So what are the values that... So by the way, since this column is satisfied, you don't have to put any values anymore. Next is satisfying this value. So in order to satisfy 300, 200 plus 100 is 300. So this is good. Now, we don't put any values here anymore. Now here, we see that there's 200. So in order to satisfy that, 100 plus 200, 100 plus 100 is 200. Then we see here 300. So we put 200. Right? So 100 plus 200 is 300, which satisfy this supply, while 200 alone satisfies this demand of 200. So this is basically it for your initial, right? So up till now, our goal was really to create the initial table. And after doing the northwest corner method, so after writing your objective function, then your constraints, and then this should be number 3, and then your cell entries using the northwest corner method, you've now created your initial table. After you've created your initial table, we can now move on to calculating the improvement index. Let's make it in black. Improvement index. Now, throughout the creation of our tables, we will be constantly calculating the improvement index, as this will determine whether or not the problem is already minimized, or if we would still be creating more tables. So let's do that. Cell entries. So next, however, before that, let's quickly do the degeneracy test. So let's grab the table again. And actually, we have to copy this. So we copy that. Okay, let me just give me a moment. You know what? Let's just merge this, selected layers, then copy. All right. So here we have our the copy of our table. And actually, let's just remove the excess. So I just did that to showcase that there's no more values there. All right. So the degeneracy test. So we just basically follow this formula. Okay. So number of used cells is actually, let's put it here. Number of used cells is equal to the number of rows plus the number of columns minus 1. Right? So in this case, what do you call this? The number of used cells would be 5, right? So this would be 5, because 1, 2, 3, 4, 5. So that's your, what you call this, number of used cells. Then here, the number of rows would be 1. So 1, 2, 3. Number of column would be 1, 2, 3 as well. So this would be 3. So then we substitute that. 3 plus 3 minus 1. So we get 6 minus 1, and we get 5. So, now remember, in calculating the degeneracy, it is non-degenerate if, the number of allocations is, just like equal to the number of used cells. So you can see here that since there is 1, 2, 3, 4, 5, which is the used cells, and after calculation, the value, or the value that would make it non-degenerate is if you have exactly 5 allocations, right? And we have 5 allocations here, so this would be non-degenerate. All right. However, it would be degenerate if, let's say, we had 4. Right? Let's just say we didn't have this value. So this would be non-degenerate. All right. So just remember, this would be degenerate, and just remember, the condition for non-degenerate is if the number of used cells is equal to the number of 5 or allocations. So that's basically it. So anyways, let's copy this table again for the next part. So we would now be moving on to calculating the improvement index. So improvement index calculation. Alright, improvement index calculation. So how do we do this? Where do we even start? So you can really choose any, but basically we are going to be targeting the empty cells, which are this, and this. So since you can start anywhere, I want to start in this cell, or FA. So how do we calculate the improvement index? We simply do it this way. So FA, or you know what, let's put it here at the bottom. So FA, the calculation of FA would be as follows. So since we're starting here, you just really have to create a closed loop using the adjacent cells. However, the cells must have values or entries in order for you to move towards those cells to create a closed loop. So what I mean is that since the adjacent cells of FA are these cells, right? The ones highlighted, we can create a closed loop. So we first go here, then go here, and then back, right? And that's possible since these have entries. If this didn't have an entry, then this wouldn't be possible. So let's do that. Okay, so we're gonna be using the cells, costs, by the way. So 9, and by the way, this follows a pattern, right? So it's 9 minus 7 plus 4 minus 8. So notice that it's minus, plus, minus, and subsequent calculations would be plus, minus, plus. But remember, we always start with minus, right? So then if we calculate that, that would amount to, so let's get our calculator, 9 minus 7 plus 4 minus 8, that would be negative 2, right? So negative 2. So then our improvement index would be negative 2. Okay. Next, let's get the value for here. So how we would do this would be going here, then here, here, and then here. And again, I'd like to clarify as well that you can also choose to go here, 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 and back, as long as there's a closed loop. And plus, the answer would remain the same. So anyways, for dB, that would be 4, right? The improvement index, minus 5 plus 8 minus 4. Then that would amount to 4 minus 5 plus 8 minus 4, 3. So positive 3. So let's put that there, positive 3. Then let's say I want to calculate this one. So EC would be 3, okay, 3 minus 4 plus 7 minus 5, right? Because 3 minus 4 plus 7 minus 5, and now we're back here. So we created that closed loop. Then with the power of the calculator, let's just do this. So this is 1. 1. Okay, so last but not the least is DC. Now notice here that in the first place, right, if we didn't have these values at all, or these entries, notice that we can't create the closed loop traditionally, right, using the adjacent cells. We would do this, do this, do this, and do this, and go back to the cell. But that's not possible since its adjacent cells are empty. So the method we've been doing all along really is the skipping stones method, right? Because you get to choose if you skip stones or not, right? However, so here, we want to calculate the improvement index, but these values are empty. So what we can do is, instead of going just here, we can skip stones. So we can go here, and then we cannot go here, right? Since this is empty. So we go here, and there's no other way other than to go here. And remember, we cannot go directly here and then go here back to the original cell since this is empty. This is a dead end. So we must first go here, and then go here, then go here, and again, this is a dead end, so we can choose to skip that, and then back here. So that is how you handle the cases wherein there's a cell that's empty, or its adjacent cells are empty, okay? So then we just follow the same thing, really. So 3 minus 5 plus 8 minus 4 plus 7 minus 5. So that would be 3 minus 5 plus 8 minus 4 plus 7 minus 5. So that's 4. So your improvement in indices for this table is now these. Now, you might be asking yourself, when do we stop creating these tables? So we stop only if there are no more negative values, because for a minimization problem, you would have your basis for creating more tables is if there's a negative, meaning it can still be minimized. So we can see here that there's a negative value here. These are not negative, but this one is -2, so we create another table. So essentially, we would just be repeating that, okay? Now next, okay, before that, however, your table here would change simply because, let's see here, -2. So when we did, what do you call this? Wait, let me quickly refer to my notes. Right, so here, since we determined that -2 is our what you call this, our basis for minimization, we need to check, we need to do this part. So this would be plus, minus, plus, minus, right? So once you've done that, you basically have to see which is smaller with the values or with the cells marked with negative. And the cells marked with negative are this and this, right? By the way, this is constant. Right away, from your improvement index that you've chosen to minimize, you start from plus, minus, plus, minus. This is constant. Then you choose between the negative, the ones marked with negative, which is smaller. Since 100 is smaller, we will be using 100 to adjust our table. Okay? So 100, so we do plus 100 here, since it is plus, right? Plus 100, minus 100, and then plus 100 and minus 100. So let's see that in action. So let me just copy the table again. Actually, I think we should just go up so that we have more space. Well, we have it here. Alright. What number are we? So 6. So now at this part, we would just really continue. Now remember, right? Our values were this one. So okay, let me just, we can do a screenshot here. Oh, why was there? That's weird. Wait. Screenshot, come on. Alright, so here we have a quick screenshot from the a copy of the table. Let's just try to adjust it a bit. Alright. So we have here, remember we're doing, since we determined 100 is smaller between 200 and 200 and 100, 100 is smaller. So minus 100 plus 100 minus 100 plus 100. So what would happen now to your table would be, oops. Wait, let me merge these, sorry. So 200 minus here, 200 minus 100 is 100. And then here in your blank value, a blank cell, blank 0 minus 100 plus 100 is 100, right? And then next here, 100 minus 100 is 0. So that would be empty now. Then 100 plus 100 would be 200. So your table would now be as follows. So still we are satisfying our constraint. Supply 100, and then 100 plus 100 plus 100 is 300. 100 plus 200 is 300, and 200. So then we just basically repeat the steps, okay? We calculate the improvement index again. So let's start with calculating the improvement index here. So FB is equal to 7 minus 9 plus 8 minus 4, and that would be 7 minus 9 minus 9 plus 8 minus 4, that would be 2. So this one is positive 2. Then I want to calculate this one first. Let's say dB equal to 4 minus 5 plus 8 minus 4. That would be 4 minus 5 plus 8 minus 4 would be 3. So positive 3. The next would be, let's say, EC. So EC would be, so remember, we have to choose the shortest path, right? We can't, although we can go here, but that's not the best path. We can go directly here, 8, and then 9. And remember, since this is empty, skip the stone. We go here and go back. So 3 minus 8 plus 9 minus 7. Oops, sorry. Plus 9 minus 5, and we're back. So this would be 3 minus 8 plus 9 minus 5, negative 1. So we would have negative 1 here. Alright? Okay. So, moving on. Let's get the improvement index for DC. DC. So 3. Okay, so how would we do this? Okay, it would be go here to this cell, and then go to this cell, back here, and finally back, a closed loop. So of course it wouldn't be here and then here because this is empty, right? This one. So that was our the best path. So that would be 3 minus 5 plus 9 minus 5. That would be 3 minus 5 plus 9 minus 5, 2. Alright. So notice again here that your improvement index, okay, there's still a negative. So meaning this can still be minimized. So what would we do now? We do what we did here. Remember the here the plus minus. However, we need to follow the path, right? Don't forget we're following the path of how we got the EC entry. Okay, for EC we did 3 minus 8. So we did this. We moved here, and then moved back. So we need to mark the cells with the signs. So positive, negative, positive, negative, because that was the path we used in order to reach and get the entry of EC. Then remember, we check which is bigger between the negative. Okay, so since 100 is smaller, okay, we choose the smaller. Then what would happen is we do the same thing. 100 minus 100 will be 0. 200 minus 100 will be 0. This would now be 200. And this would be 100. Okay? So let's just copy the table again. So we're really just continuing, okay? We're continuing until we finish. So actually, let me grab a clean table. Where's my table? Come on. Hello? Here it is. Alright, so we're really just continuing at this point. Okay? So based on the given, okay, let's take a quick screenshot again. So we have a point of reference. Bro, come on. Not this. I want a screenshot. Alright. So we have that there for our reference. So let's quickly fill in the values again. Well, that was 100, right? And 200, right? What else? Yeah, let's just put all the values first. 100, 200. Right. So remember, we would be using 100 to subtract from all your value, the values, right, from your path. Okay. That we forgot the. Oh, okay. That no need. So here 100. Since this is smaller, like between 200 and 100, the negative values, this is smaller, so 100. So 100 minus 100 would now be just 0. Okay. Then 100 plus 100 here, this would turn to 200. Then here would now be 100. And last but not least, this would be 100. Okay? So then we just really repeat from that. So this is just a continuation. Okay? Continuation. So the goal really here is until you have no negative values, meaning it cannot be minimized further since you're already at the most like minimal state, okay? The most minimized state. So next we do the same thing. Let's get for E8. E8 is equal to, so we go from here, then here, and back. So for 8 minus 3 plus 5 minus 9. So 8 minus 3 plus 5 minus 9 is 1. Okay, so this will be plus 1. And then let's get this dB. So dB would be, okay, so dB would actually quite be complicated. So dB, so we're getting this. Okay, so how we would do this would be from here, and then we go here. Yeah, so we cannot go here since it's a dead end. We cannot go here as well to make an easy closed loop since it's a dead end. So we go here, then go here, yep, and then go here, and then back. So I hope you got that. Sure. 4 minus 4 plus 3 minus 5 plus 9 minus 5 again. So the answer would be 4 minus 4 plus 3 minus 5 plus 9 minus 5 is positive 2. Right? So let's put it there. Positive 2. Oh, wait, sorry. Positive 2. Then let's get for DC. So DC. Okay, so let's analyze this. So the best path would be here, 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 and then back. We can't go here and then directly here since this is a dead end. So let's calculate again. 3 minus 5 plus 9 minus 5 is equal to 3 minus 5 plus 9 minus 5, 2. Now, last but not least is FB. So FB is not complicated because its adjacent cells have entries, right? So we just do the following loop. Just the usual. So 7 minus 5 plus 3 minus 4. Oh, sorry, we didn't put. Okay. So 7 minus 5 plus 3 minus 4, it's positive 1. Okay. So, wait, let me just double check. 100. Because I also have my notes here. Yeah, right. That's right. Okay, so positive 1. Right? Okay, so positive 1. So notice here now that there are no more negative values or 0 or values containing 0. So, meaning this table here is now minimized. Okay? And we can even check that with the transportation cost. So, let's see, what number is this? So 7, we could now, or let's just quickly write it here. So how do you calculate the transportation cost, or TC? That would be all the values with values, all the cells with entries. So 5, 100 plus 9 times 200 plus 4, 100 plus 3, 100 plus 5, 100. So how do we get these values? It's here. So 5 times its entry, 100, then 9 times 200, and repeat for all your, so 4, then 100, 300, 3 and 100, 5 and 100. Okay? Only the ones that have cells, that have entries. So if we were to calculate that, plus 9, 200, plus 4, 200, plus 3, 100, plus 5, 100, that will be 3, 9. Right? And actually, we can see here that from the very first, when we calculate the transportation cost in our very first or initial table, right? So that would be TC. So 5, 100 plus 8, 200. I'm just gonna wrap it here. 4, 100 plus 7, 100 plus, last but not the least, 5, 200, which would amount to 500 plus 8, 200 plus 4, 100 plus 7, 100 plus 5, 200. So the answer will be 4,200. So this is proof in and of itself that from the very first initial table, 4,200, we managed to minimize it up to 3,900. So a difference of 300. And that's basically it for your transportation method using the skipping stones method and the northwest corner method.